Let's talk about a subject that, makes a lot of people just a little bit nervous: algebra. But I want you to try something with me. For the next few minutes, forget about math. I want you to think of algebra as a language of pure logic that's designed to describe the world around us with perfect precision. Okay, let's just dive right in. Take a look at this. Now, if this expression on your screen seems a little intimidating, maybe just a jumble of numbers and letters, you're definitely not alone. That is a completely normal reaction. I mean, it kind of looks like gibberish, right? And that's totally fine. It's really no different than trying to read a sentence in a language you haven't learned yet. But here's the secret. Just like any language, once you learn the basic grammar and a little vocabulary, everything just clicks into place. So here's my promise to you. In just the next few minutes, I'm going to hand you the translation key. By the time we're done here, you won't just see a bunch of symbols. You'll be able to read this expression, know exactly what it's asking, and find the solution. You're going to be the translator. First things first. Every language has grammar, the rules that give it structure. Well, in algebra, our grammar is called the order of operations. Just think of it as the universal rulebook. It's the thing that makes sure everyone reading the same mathematical sentence gets the exact same meaning. And this grammar has a name you might remember: PEMDAS. It's our roadmap. First up is P for parentheses. You always start inside those. Then E for exponents. Next, M and D for multiplication and division. Now this is key. You do these as they show up from left to right. And finally, A and S for addition and subtraction. Same deal, left to right. This order isn't a suggestion, it's the law. All right, let's put this grammar to the test. Take a look at this expression. How would you solve it? Think about PEMDAS. What's the very first move we need to make? You got it. Okay, so no parentheses here, so we jump right to E, exponents. 2 squared is 4, so now our expression reads 5 times 4 minus 5. According to PEMDAS, multiplication comes before subtraction, so 5 times 4 gets us 20. And the last step is easy. 20 minus 5 is 15. See? It's like a roadmap, and following that grammar led us straight to the answer. So we've got our grammar down. Now let's build up our vocabulary. Algebraic expressions are made of different kinds of words, which we call terms. Our job is to figure out how to sort them, almost like fitting puzzle pieces together. And this whole process is called combining like terms. So what in the world are like terms? It's actually really simple. They're just terms that have the same variables raised to the same power. Think of it like this. Your A terms are apples, and your B terms are bananas. You can add all your apples together, and you can add all your bananas together, but you can't just mash them into one big group of banables. Let's try one. Here we have a whole mix of terms. Some of them have the variable x, and some are just plain old numbers, which we call constants. The very first step to making sense of this is to find those matching puzzle pieces, to spot our like terms. And here's how we sort it all out. We're going to group all the x terms together and all the plain numbers together. So 4x plus 9x plus another x gives us 14x. And then 8 minus 3 gives us 5. And just like that, that long, messy expression becomes a nice, simple 14x plus 5. So much cleaner, right? Okay, let's add another really powerful tool to our kit. Sometimes you're going to see a number sitting right outside a set of parentheses. There's a special rule for this. It's called the distributive property, and trust me, it's an amazing shortcut for cleaning things up. The rule is actually pretty simple. You distribute the term on the outside by multiplying it by each and every term on the inside. So A times the group B plus C becomes AB plus AC. In a real problem, something like 4 times x minus 9 becomes 4x minus 36. All right, your turn. Take a look at this expression, 7 times the quantity 4a minus 2. Using that distributive property we just talked about, how would you start to simplify this? What's that very first step? Yep, you got it. We distribute that 7 to each term inside those parentheses. First, 7 times 4a is 28a. Then, 7 times 2 is 14. So our simplified expression is 28a minus 14. And notice, the most important part here, the parentheses are gone. Distribution is the key to unlocking them. And now we get to the really fun part. We've learned the grammar, we've learned the vocabulary. Now we can take one of these abstract expressions and find its actual concrete numerical value. This is called evaluating, and it's where algebra really truly comes to life. Hey, look who's back. It's that same expression that might have looked like gibberish just a few minutes ago. But guess what? It's not gibberish anymore because now we have all the tools we need to translate it. We're told that x is 2 and y is 4. So let's do this. First step, we substitute or plug in the values. The x becomes a 2 and the y becomes a 4. Now we just follow our grammar, PEMDAS. We have to solve inside the parentheses first. So 9 times 2 is 18, and 2 times 4 is 8. That simplifies to 18 minus 8, which is 10. And the final step, multiply by the 2 waiting outside, and we get our answer, 20. See? Not so intimidating anymore, is it? But the real power of this language, it isn't just about solving abstract puzzles on a page. It's about taking messy, real-world situations and translating them into clear, simple expressions that we can actually solve. Let me show you how that works. So this is Tom. He's learning 7 Ojibwe words and 5 Dakota words in each of his language sessions. We can translate his progress into a simple expression, 7x plus 5y. In this case, x just stands for his number of Ojibwe sessions, and y stands for his Dakota sessions. We just told his story in the language of algebra. So let's say Tom goes to 6 Ojibwe sessions and 4 Dakota sessions. How many new words has he learned? Well, we just plug those numbers right into our expression, 7 times 6 plus 5 times 4. That's 42 plus 20, giving us a grand total of 62 new words. The language of algebra gave us a perfectly precise answer. This language is also super useful for everyday decisions. I mean, we've all been here. You're standing in the store, staring at the shelf, faced with a choice. Biggie soap gets you 120 ounces for $15. But Miggy soap is cheaper, only $9, but you only get 66 ounces. How do you know which one is actually the better deal? Algebra's got the answer. To find the real value, we translate this into what's called a unit rate. Basically, the cost for just one single ounce. We just divide the price by the ounces for each one. For Biggie soap, that comes out to about 12.5 cents per ounce. But look at Midgie soap. It's over 13.5 cents per ounce. So as the chart shows, that bigger, more expensive-looking bottle is actually the better buy. So you see, algebra isn't just some random class you have to take in school. It's a language. It's a way of describing relationships, of making smart comparisons, and of finding real answers. It's a really powerful way of thinking. Which, I guess, leads me to one final question for you. Now that you can read the language of logic, what problems will you solve?